We have discussed async await task in detail. Just for revision, async await should be done for IO operation, not for heavy compute. And also discuss about synchronization context. But we want to discuss further about in detail about what happens internally when you write async await. So here is a simple method which returns task string, and we await for fetch from server async method. So this looks very simple, right? We are waiting, but what happens internally is that a compiler rewrites this method as a class. A state machine is written. That class creates a I async state machine implementation. So we'll see a simple example in next slide. uh, After this slide we'll go. So what happens, the code before await is one state, the code after await is another state, so it is disconnected. Each await introduces a new state. The compiler generates a struct class as we discussed. It implement async state machine, contains field as state fields. So see, logically, uh, the task runs on task or thread has its own call stack, right? So if you want to do certain operation, you will save something, right? So save it in some variable. So here we call it as state machine. So that's what major point is. See, this doesn't come helpful, but it is very good, important to understand that async await is a sugar coating, syntactical sugar over a complex task which is done by the compiler. So it is good to know from, and then it contains move next method if we have multiple states. So the await keyword does not block. We already discussed this in it yields control to another caller. When the awaited task completes, the state machine resumes from where it left off. So this example will make things clear. We are waiting for a task delay and we are doing console.write line. This is much more readable. But what happens internally is the switch state statement is created, case 0, case 1. So if you see here are the first line await, awaiter is this line, and then it checks if it is completed. If sometimes what happens, the class the task gets completed immediately, right? So it assign it to state 1, and the awaiter goes into uncompleted state. So when the case 1 gets triggered, awaiter get result is called, and console the second line console dot write line done and break. So this is hidden from us. So in the next session, we will discuss in from code perspective how ILDSM basically creates this switch test. This is for simpler understanding. I have created this example for you to understand, but we'll see in depth in code wise how you can verify this switch state statement. Let's try to understand async await state machine from code perspective. So here I have a main method, a synchronous code, fetch data, and we are console writing the data in HTML. Basically, we are downloading HTML response from example.com and printing it in the console. So if you see here, we get output of HTML and we are printing. So if we open this in ILDSM, we will see something similar. Let's see this in ILDSM. To open ILDSM, go to start menu and type developer command prompt for Visual Studio 2022. Once the command prompt is initialized, type ILDASM. So ILDSM will open. We will open the DLL which we are trying to decode. Expand the program class. If you see here, it is simple main method is there, void, which has a fetch data and console.write line. Fetch data and console.write line. So I'll take a screenshot of this to let's compare this with async await later. So I'll close this because DLL is in use. So now this is IO bound operation, right? This is not the, so here it is good example to convert it into async await. So we need to first convert this method into async, and as we are converted it to async, we need to change it to task string. We remove the asynchronous code and we'll await the get string async. So this has become asynchronous, but we had to convert this into await this method. So this is not async yet, so we need to change it to async. We cannot return void, we have to return task. So this, let's build it. So let's run this application. So you can see HTML response is coming. So basically it is same code, but we have optimized it, converting into async await operation. So let's see this state machine in ILDSM, because from code perspective everything is syntactical sugar, right? As we discussed, a class will be created into these methods will be converted into class. The class will be implementing an interface async state machine, and there would be switch case statement. This will be a complicated code with in the IL code. So let's look at in ILDSM. Let's open ILDSM. Let's load the same DLL. Expanding this, I am bringing the original screenshot as well. If you look closely, we got this blue classes, extra classes, fetch data and the main. So if I go expand this main, this was not there initially. It was plain vanilla class primary, but these two are added now. These are, if I open the class instance, you can see it implements async state machine interface. And if you open move next, you will see we are overriding move next, and here is the entire code. So a simple code has become complicated internally, but it is optimized for IO operation. It is like the state, the first state, uh, previous state, second state is now combined, before awaiter and after awaiter. So this is what I wanted to discuss about async await in depth. It is like not methods at the end. This becomes a class which implements async interface, and it has a move next method, switch case statement. So this has become, life has become simpler using our async await, but the complexity is handled by the compiler. Thank you. Thank you for watching this video. This video is from a course available in Udemy. The link will be available in description. In this course, we deep dive into .NET threading concepts like introduction, high level threading concepts, fundamentals of thread, when to use tasks, threads, async await, synchronization context, mutex, pin lock, auto reset event, and I have also provided link for GitHub, which is available. So here you can see, get the PPT, as well as the codes which are used. This you can use for freely. Examples, I would encourage you to fork it and play around with it. And PPT, if you see example, I have used analogies to make things much clearer, like auto reset event can be considered as a turnstile, manual reset event can be considered as open gate, semaphore as a printer which is taking only for a few jobs, countdown event like rocket. So things you will remember for long time. The conceptually everything is explained properly. So please, if you have time, check my courses and check GitHub link. Thank you very much. Have a good day.